The standard error of the mean is the standard deviation divided by the square root of the number of independent measurements, and it estimates how uncertain the calculated average is. Think of taking the same measurement many times, like timing how long it takes for a chemical reaction to finish, and then averaging those times. The standard deviation tells you how spread out the individual measurements are around that average, while the square root of the number of measurements shrinks that spread when you compute how well the average represents the true value. So, if you have more independent measurements, the standard error gets smaller and your average becomes more reliable, because random measurement noise is reduced. If the measurements are noisy or not independent, the standard error will not accurately reflect the true uncertainty in the average. A common mistake is using the standard error when the data are not independent, which makes the uncertainty look too small. Check that measurements are taken independently, and if they are correlated, use methods that account for correlation. Another mistake is confusing standard error with standard deviation and reporting the wrong value. Remember that standard deviation describes spread of measurements while standard error describes uncertainty in the mean. A third mistake is thinking more measurements always fix systematic errors. Repeating biased measurements reduces the standard error but does not remove a consistent bias, so identify and correct systematic errors separately. For more videos and resources about measuring uncertainty and the standard error of the mean, please visit www.gumballdegree.com.